Welcome to Nano Matters, the podcast that explores examples of nanotechnology. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Here with me today is David Zamarin, CEO and founder of DetraPel, a nanotechnology-enabled protective coatings company. So David, your company makes coatings that protect clothing and fabric from stains. How are these coatings used?
Great question. They're used in a variety of ways. We typically see that most applications are made for one of three purposes or a combination of three purposes. And the first one is to save time and or money by applying the coating onto, let's say some kind of surface that typically gets stained. By applying this coating, you don't have to necessarily clean that surface or it won't get any stains. So thereby you're saving time and or money. And so those are the two big categories of why people or where this can be applied. And the third one is for convenience and sake of mind, right? The fact of the matter is when you apply a coating, a protective coating, it's not something that you do reactively, you do it proactively. And so when you apply a coating, whether it's, like let's say an anti-graffiti coating or a direct food contact coating for food packaging, for example, you're doing that proactively to prevent something from happening and to keep that sake of mind. So that's kind of the third bubble, so to speak, that we have of what the products are used for.
So what motivated you to make these coatings?
I was just on a quest to really solve a small niche, which was to keep my shoes clean as a freshman in high school. But eventually that turned into something very, very much different. Now our mission is really to try to make a huge impact in the world because all of our coatings are PFAS free, which is fluorochemical free. And although, many fluorochemicals are very advantageous in their certain industries and have their benefits, for the vast majority of industries, and in particularly our industry, although this chemistry is, highly effective, it's certainly also a deterrent to many different things like public health and the environment. And so what we're trying to do is effectively replace the need to use any fluorinated chemistry in industries that don't really require that. And protective coatings industry is a massive one. If you can achieve the same type of performance with fluorochemicals that you can with something like our coating, then I think you have a sure winner. And that's kind of where we are. We have a product that performs very well compared to PFAS coatings.
So now that we know why you're making the coatings, let's go into a little bit of how they work. So how do you make them and how do they give you this performance?
Yeah, we have a very proprietary process of how we make the actual particles. We synthesize a lot of our own chemistry, so that's a big component of what we do. And we have some specialized equipment that allows us to be able to get some of the particles that we're using into solution without using a solvent-based carrier. And that's a big, big component as to what we do. Most products in the space, especially on the fluorochemistry side, is a pretty straightforward technology. When you try to move away from the fluorochemical technology, if you want to achieve hydrophobicity, that also already exists technically, especially if you want a heat cure. That's a pretty widely available product on the market. That's where you see these DWR coatings, the durable water repellents, although most of them are fluorinated, but there are ones that are not. When you want to add any oleophobicity or air dry for consumer use, that's where things get drastically different. And we're able to achieve that the way that we incorporate our particles in addition to the actual chemistry as well.
So how does nanotechnology play a role?
The components are on the nano scale. We have a few different types of, for example, silicas that we have in there, which are all fumed silica. So they're not detrimental. They don't lead to silicosis. And we were very careful about using crystalline silica as opposed to what we currently do. There are multiple different types of particles that are on nano size. And the way that the particles work is that, again, they're so highly effective because they're so small and able to give great performance. We don't have to use a lot of them into the formulation to get the performance that we need. So the percent of active solids in the formulation is actually not that high compared to some of these other chemistries out there. And the reason is because we are using nanoparticles.
How do you envision these coatings are going to be able to impact different areas into the future?
Well, I think you're starting to see a lot of impact in general with protective coatings and the industry as a whole. If you look at just a few weeks ago that McDonald's announced that by 2024 or 2025, they're going to go completely PFAS free in their food packaging. Now, that's a really bold statement because there aren't technologies out there right now that can achieve the oleophobicity that's needed in a food package that holds McDonald's burgers. So I think ultimately what's going to happen is, there will be coatings or there will be developments on how to create the same type of performance as what a fluorochemical protective coating could get you, perhaps without the need of fluorochemicals. And I think the market is going to kind of gear towards a heat cure product in the near future, because I think that's the only way that people think it's achievable. Hopefully our company becomes a big player in the space, and we can showcase that you don't need necessarily heat cure to get that same kind of result. So ultimately, I think a lot of products like firefighting foam and certain other products on the market will ultimately be replaced by these legacy fluorochemical brands, which have their pros and cons, right? The pros is that, you get rid of forever chemicals and there's a big advantage there. The con is that with the existing technology on the market, besides ours, at least I would say, you may lose performance. But again, we believe that you can achieve that same quality performance as fluorochemicals can without the use of them.
So you call these protective coatings or nanotechnology-enabled protective coatings. And, there's protective coatings for corrosion resistance or scratch resistance, or, what are you trying to accomplish with your type of coating?
Well, our core fundamental technology is widely applicable in all of our products. So we do use the same core technology in many of the other types of coatings that we're developing. But yeah, the primary thing that I started the business with was for textiles. So that's where it started. And that's where I think there is a definite immediate need, because there are existing coatings, and a lot of them in the market today, that are fluorinated. But if you look at any other coatings, even like an electric car battery, for example, uses nano-based coatings to make them either A, more efficient, or B, resistant to weather. So there are weather-resistant coatings. There are, like you mentioned, anti-corrosive coatings, anti-graffiti-based coatings, scratch-resistant. There's a ton of different stuff out there. And where we started originally with textiles was just, a vision. But the goal and the ultimate kind of mission that we're on is to get into all types of protective coatings. And that's why we take R&D so seriously. I mean, for a small business that we are, to have 4 people, and 2 of which are incredibly experienced senior staff members, those are a lot of resources to have at your disposal. And to have custom equipment like we do, it's not commonly found at our size. But we recognize the importance of what we're trying to do and the wide range of applicability that we'll have as long as we're able to achieve the core technology, which we think we have. We can be able to put this, like right now we're working on actually a glass coating, which will help with anti-fogging. And on the flip side, there are other coatings that are already doing this, but now without fluorochemicals. We're looking at solar panel applications to increase the efficiency of solar panels, UV resistance for buildings. And so any of the coatings that we try to work on, we try to have a very wide range of applicability. And fortunately, with specialty coatings and protective coatings in particular, that's very achievable.
David, I want to thank you for taking the time to talk with us. Do you have any closing thoughts that you would like to share with our listeners?
I would say for any non-technical listeners, I would really encourage you to not get discouraged if you're interested in starting something, or if you're just interested in any technology whatsoever. And if you think you have no idea what you're talking about or what the product is about, I really strongly encourage you to do some research, and you'll actually be able to learn quite a bit and not get scared of some of these fancy terminologies that are commonly thrown around in different industries. And so if I'm a living testament of that. I didn't know anything about chemistry. That wasn't my main background when I was studying in undergrad. And similarly, like my COO, he claims his worst subject in high school was chemistry. So, I think many people, if they put their minds to it, they're more than capable of trying to learn at the very minimum about a new industry. When it comes to like hardcore research, then yeah, maybe you have to take a little bit more time and learn a little bit more. But if you're just trying to dabble, if you're just trying to learn, don't be scared. It might seem complicated, but as soon as you get past some of the terminology and you understand how the fundamentals work, it all starts to pile up and make sense.